Hello students, welcome to Eshwari Thaniksha channel. Students, today we are going to analyze NEET 2024 question paper, how the questions are appearing from organic chemistry and how you have to approach. So students usually find difficult in solving this organic chemistry questions. So today we will see how to approach in solving these questions from organic chemistry. So students, if you see the types of questions, usually three types of questions will appear from organic chemistry. That is easy, moderate and difficult level. So each questions we are going to analyze and tell you how to approach the questions and how to find the answers for them. So let us see the first type. So the first type is easy questions. That is, the questions will be directly picked from the NCERT textbook. So continuously 2 to 3 times at least you have to keep revising every day so that easily you can answer these questions. So no need to waste your time in the NEET examination. Direct question will be asked and you can answer this. Second is moderate type of question. So in moderate type of questions, how the questions will appear is, two statements will be given, statement 1, statement 2, and you have to say whether it is true or false. Or another type of question which can be asked is assertion and reasoning type of questions will be asked. And third type of question is difficult question. So this is where students find it difficult in solving the questions. So it is reaction based. So usually in a reaction based questions, how it will be asked is, A will react with B and it will form C. C will give D. So you have to find what is C and what is D. Or you have to find out what is the reagent used. So such type of questions will be asked. So students, what they will do is, they will think from one particular chapter. So usually whenever reaction based question is given, so from 2 to 3 chapters it will be mixed together and the question will be framed. I'll show you with the example how the question is framed and how you have to think in order to answer those questions. So now let us start. So here you can see statement questions are given. So these are moderate type of questions. So given below are two statements. The first statement is, the boiling point of 3 isomeric pentanes are as follows. N-pentane is greater than isopentane is greater than neopentane. So boiling point they are asking. So you can see this table. So refer this table, that is 9.2. So you can see pentane, isopentane, neopentane is given and see their boiling point. It is increasing in this direction, 309, 300, 282. So here this statement what is given is correct. Second statement is, when branching increases, the molecule attains the shape of a sphere. This results in smaller surface area for contact, due to which the intermolecular forces between the spherical molecules are weak, thereby lowering the boiling point. Even this statement is directly picked up from NCERT textbook. So see here, with the increase in number of branch chains, the molecules attain the shape of a sphere. This results in smaller area of contact and therefore weak intermolecular forces between the spherical molecules. So even this statement is true. So both the statements are true. So you can write both the statements are true. So students, here this is pentane, this is isopentane and this is neopentane. Where the branching is more, see here one branch and here two branches are present. So remember this trick. So boiling point is inversely proportional to branching, meaning is more the branching, boiling point will reduce. So here the branching is more, therefore the boiling point is going to reduce. So you can see here the boiling point is reducing. So this is the trick. So write and learn. So this is the trick which you are going to use. Second type of question you can see, this is the match the following which is given. So here one side molecules are given and here what they have given is number and types of bonds between carbon atoms. You have to see how many sigma and pi bonds are present. So the first one which is given here is ethane. So this is ethane. Between carbon and carbon, one sigma bond is present. Second is ethene. So between carbon and carbon, one sigma bond and one pi bond is present. Third is carbon molecule. So students always remember, in carbon molecule 2 pi bonds will be present. Make a note of it. And then ethine. So in ethine, between carbon and carbon, one sigma and 2 pi bonds are present. So you have to match and get the answer. So this is very simple one. So next type of question is, which of the following alcohols react instantaneously with Lucas reagent? So students, here instantaneously meaning is immediately, which will react with Lucas reagent. So here you can see in Lucas reagent what is given is, in case of tertiary alcohol, the turbidity is produced immediately. So meaning is tertiary alcohol is reacting instantaneously with Lucas reagent. So here find which is tertiary alcohol. So here this is primary alcohol. So OH group is attached to primary carbon. Here OH group is attached to tertiary carbon. Here OH group is attached to primary carbon. OH group is attached to primary here the OH group is attached to secondary carbon. So this will be your answer. Next question. So this is from biomolecules. The reagents with which glucose does not react to give corresponding test or. So here you can see from biomolecules, page number 285. So students, this is from new textbook, page number I am giving. So refer new textbook. So here it is given, despite having the aldehyde group, glucose doesn't give Schiff's test, and you can see doesn't form hydrogen sulfide addition product with sodium bisulfite. So here it is not giving Schiff's reagent and then sodium bisulfite. So this will be the answer. So next question is, intramolecular hydrogen bonding is present in. So intramolecular meaning is within the molecule hydrogen bond should be present. So always remember that in ortho position, if it is present in the ortho position, here intramolecular will be present. If it is present in the para position, then intermolecular hydrogen bonding will be present. So in case of para, you will see inter, and in case of ortho, you will be seeing intramolecular hydrogen bonding. So you can see this from alcohol, phenol and ethers, page number 211. So here it is given, see, orthonitrophenol is steam volatile due to intramolecular hydrogen bonding, while para-nitrophenol is less volatile due to intermolecular hydrogen bonding. So make a note of this. Next question is, given below are two statements. So again you can see two statements are given. Aniline doesn't undergo Friedel-Crafts alkylation reaction. So here you can see from the textbook, aniline doesn't undergo Friedel-Crafts reaction, that is alkylation and acetylation, due to salt formation with aluminium chloride. So you know that you will be using anhydrous aluminium chloride for Friedel-Crafts reaction. So therefore aniline doesn't give alkylation as well as acylation. So here the first statement is true. Second statement, aniline cannot be prepared through Gabriel synthesis. So here you can see aromatic primary amines cannot be prepared by this method. So you know that aniline is a aromatic amine. So therefore you will write both the statements are true. Next question is, identify the correct statement that would bring about the following transformation. So students, here even this is a simple reaction. From one chapter the reaction is taken and given to you. So here you can see, observe the reaction carefully. So here what is there? There is a double bond. In the product, what it is converted to? It is converted to aldehyde. So you have to select the reagent. So this is from the chapter aldehyde ketones and carboxylic acid, page number 200 and 210 if you refer. So you can see here hydroboration oxidation reaction. So that is when you are using diborane, so diborane will react with alkane, so that is hydroboration, and oxidation will also happen, that is hydrogen peroxide in the presence of sodium hydroxide. So see here, diborane, hydrogen peroxide in the presence of sodium hydroxide. So here you can see diborane, hydrogen peroxide in the presence of base. So base here is sodium hydroxide. So what it is going to give? It is going to give primary alcohol. And then see here, primary alcohol will be converted into aldehyde. A better reagent for oxidation of primary alcohol to aldehyde in good yield is pyridinium chlorochromate, PCC. So PCC is used for conversion of primary alcohol to aldehyde. So you can see here this option PCC. So first is hydroboration and then oxidation, and then PCC will be used to convert alcohol to aldehyde. So this is how you have to check the reagents which is present here. So here you are converting double bond to aldehyde. So you have to check which reagent you have to use. So next question, match the following. So here reagent is given, reactant is given as well as the product is given. So you have to find the reagent. So here you can see there is a double bond. So double bond is converted to ketone. So when double bond is converted to ketone, so what is the reagent which is used? So here you can see from the hydrocarbon chapter, page number 313. That is ozonolysis. So when you are treating with ozone and then when you are treating with zinc in the presence of water, you are going to get ketone. So ozone in the presence of zinc and water, you are getting ketone. So this is first one. Second, you can see here benzene is converted here. So there are two benzene ring and then there is one keto group here. So that is nothing but acyl group is added. So this is nothing but Friedel-Crafts acylation reaction. So here you can see acyl group is added to this benzene ring. So see, this is from the chapter aldehyde, ketones and carboxylic acid. Refer page number 234. So you can see there is a benzene ring and here there is a acyl group. In the presence of anhydrous aluminium chloride, you can see the product will be formed. And third is, here you can see alcohol again is converted into ketone. So here this is from the chapter alcohol, phenol and ether. So here secondary alcohols are oxidized to ketone by you can see here chromic anhydride, CrO3. Chromic anhydride is used to convert secondary alcohol to ketone. So refer page number 210. So that is the third one where secondary alcohol is converted to ketone. And fourth one is, here you can see benzene ring to this alkyl group is attached and this alkyl group is converted to acid group. So here this is from the chapter aldehyde, ketone and carboxylic acid. Refer page number 246. So here you can see a side chain which is alkyl chain. So alkyl group is attached to benzene. When you are treating with KMNO4 and KOH, what you are getting is carboxylic acid group will be attached. So you will have to match this according to the reaction. Next type of question is the compound that will undergo SN1 reaction with the fastest rate is. So students, you know that SN1 reaction will proceed through carbocation formation. So stable the carbocation formed, the rate of reaction will be faster. So this type of question is given in this example, you can check. So example 6.7 if you see, predict the order of reactivity of the following compound in SN1 and SN2 reaction. So here in this it is given carbocation intermediate, if it is more stable then the rate of reaction will be faster. So here find which carbocation is more stable. So here the carbocation will be formed here, so which is stabilized by resonance. Therefore this will be the answer. Next question is This is direct from NCERT, easy question. Filling solution A is, so you know that filling solution is made up of A and filling solution A and filling solution B. So you can see here filling test. So filling's reagent comprises of two solutions, filling solution A and filling solution B. Filling solution A is aqueous copper sulfate. So that is what is asked, aqueous copper sulfate. So always remember what is filling solution A and what is filling solution B. Next question is, the most stable carbocation among the following is. So here you know that the order of carbocation stability, that is tertiary carbocation is more stable than secondary, which is more stable than primary. So here a tertiary carbocation is formed, therefore it is more stable. So next question is, a compound with molecular formula C6H14 has two tertiary carbons. So here you can see this is the molecular formula. So 6 carbon atoms should be there and 2 tertiary carbon atom should be there. So this is one tertiary carbon and this is second tertiary carbon. So IUPAC nomenclature. So you have to write there IUPAC name. So students, if you have any doubts in IUPAC nomenclature, I have made some tricks on writing the IUPAC name. So go to the playlist and check for the IUPAC nomenclature. So you can see a video where I have taught you the tricks in order to name give the IUPAC name for the compound. So 2,3-dimethyl butane will be the answer. Next question is, major product A and B formed in the following reactions. So here you can see a reactant is given and product A and product B you have to find. So first we will see. So here you can see when alcohol group is reacting with PBr3. So what is the product obtained? So this is from haloalkanes and haloarenes. So you know that when you are treating with PBr3, OH group will be replaced by Br. So here you will be getting Br. So that will be the major product. So here you can see this is the product. So you will be getting Br here. Second is you are treating with alcoholic potash. So KOH is nothing but potash. So when you are treating with alcoholic potash, dehydrohalogenation will take place. That is, hydrogen and bromine will be removed and double bond will be formed. So here you can see the bromine is attached to this carbon. This carbon is called as alpha carbon. Next carbon is called as beta carbon. So this is one beta carbon and here one beta carbon is present. So from the beta carbon, hydrogen will be removed. So from this beta carbon, hydrogen will be removed and here one double bond will be formed. So here you can see double bond is formed. So here you can see this is nothing but elimination reaction. That is, when haloalkane with beta hydrogen atom is treated with alcoholic solution of potassium hydroxide. So you can see there is elimination of hydrogen atom from beta carbon and halogen atom from the alpha carbon atom will take place. So this is the reaction. Next question is, for the given reaction. So here you can see a reactant is given and you are treating with KMnO4 in acidic medium. What is the major product formed? So students, you know that acidic potassium permanganate or acidic potassium dichromate, when you are oxidizing alkene to ketone or acid depending upon the nature of the alkene. So students, here there is a alkene. Can you see here? CH double bond CH. So this is a symmetric alkene. So you have to check whether it is symmetric alkene or unsymmetric alkene. If it is symmetric alkene, it will give acid. If it is unsymmetric alkene, then it will give ketone. So that is what is given here. So see here, this is unsymmetric alkene, so it will give ketone. If it is symmetric, it will be giving acid. So here for us there is symmetric alkene, therefore acid will be the product. So next question is, identify the major product C from the following sequence. So here you can see there is alkyl group attached to iodine. You are treating with sodium cyanide. So A will be formed. When A is treated with partial hydrolysis, product B is obtained. When product B is treated with bromine in the presence of sodium hydroxide, C is obtained. So what is C? Final major product you have to check. So first we will see when when alkyl iodine is treated with sodium cyanide, what is the product obtained? So from haloalkanes and haloarenes, you can see here sodium cyanide or potassium cyanide if it is there. So when it is treated with alkyl halide, CN will be attached to alkyl group. So always remember here two types of cyanides are there. So one is potassium cyanide or sodium cyanide, another is silver cyanide. So sodium cyanide or potassium cyanide, these are ionic compounds. So if it is ionic compound, it will form cyanide. CN will be attached to alkyl group. So here remove this I and attach CN to this. So here CH3, CH2, CH2, CN you will get. So that is A. So now partial hydrolysis of this. So let me write here CH3, CH2, CH2, I. So this one when you are treating with sodium cyanide, when you are treating with CaCN, so this you are replacing with CN, that is CH3, CH2, CH2, it becomes CN, C triple bond N. So this you are partially hydrolyzing. So this is from the chapter partial hydrolysis. This is from the chapter aldehydes, ketones and carboxylic acid, page number 246. So see here what is given. Nitriles or nitriles are hydrolyzed to amide and then to acid. So if you are partially hydrolyzing in the presence of acid or the base, it will result in the formation of amide. Complete hydrolysis will lead to acid. For us, they are asking for partial hydrolysis. See here, partial hydrolysis in the presence of a base. So partial hydrolysis, we will be getting amide. So here, partial hydrolysis. So when you are partially hydrolyzing with the base, so you will be getting amide. So CH3, CH2, CH2, you will be getting here CONH2. So you will be getting amide. So what is next? You are treating with bromine in the presence of sodium hydroxide, that is base. So this is nothing but Hoffman bromamide degradation reaction. So this is from the chapter amines. See what is given. So when you are treating with bromine in the presence of a base, what will happen is you will be getting amine. Amide will be converted into amide. The amine so formed contains one carbon atom less than the present amide. So in amide you see how many carbon atoms are there. So in the amine one carbon atom will be less. So here, so we are going to get amine. So one carbon atom should be less. Here you see how many carbon atoms are there. 1, 2, 3 and 4. So in the product we should get one carbon atom less. So it should be 3 carbon atom. CH3, CH2, CH2, NH2. So this is the final product for us. So what is this? Amine group is attached to propyl group. So the answer will be propyl amine. So this will be the answer. So this is how you have to solve the reaction. So if it is reaction based, so always think from 2 or 3 chapters the reactions will be picked up. So here you can see 3 reagents are given. So 3 reagents are given from 3 different chapters. See, first from haloalkanes and haloarenes, second from aldehydes, ketones and carboxylic acid, and third is from amines. So think from different chapter, the reactions will be picked up and one question will be framed. So don't think from one chapter itself it will be picked up. So think from different chapters, the reactions will be picked up and one question will be framed. So this is how you are going to solve the questions. So students, I hope the video is useful to you. So if you are finding it useful, share this video with your friends and also subscribe the channel. I'll meet you in the next video, students. Prepare well for your examination. All the very best.